Okay, so this video is on graphing quadratic functions. So the first thing we did was we did factoring, and then we solved, and then this is going to be about how you graph. So you're going to end up doing a lot of the same stuff you've been doing with factoring and solving, but we're going to use that now to graph. So why do I have this paper in front of me that says, let's review linear equations? Well, the reason I do is because I want you to relate what I'm about to do with quadratics to what you already know about linear equations. Now with linear equations, in terms of graphing them, you know that this one here, this number, this constant on the end, that's my y-intercept. And if this is the y-intercept, what that means is that if we have a graph, that the line is going to go through the 3. Okay, that's what a y-intercept is. It's where the line is going to intersect the y-axis. And then if we want to find what the x-intercept is, what you do is you make y equal to 0. So you end up with an equation like this. You do additive inverse with the 3. And then you do multiplicative inverse with the 2x. And you end up with negative 3 over 2 is equal to x. And you write that as an ordered pair. So you have this 0. This one would, of course, be 0, 3. So this is 0.03. This is now negative 3 over 2, 0, which would be about here. So if we connect our x-axis, our x-intercept to our y-intercept, then we have the line. Okay, so this is, of course, one way to graph a line. But if you're doing quadratics, which you are now, you probably already know this. This one right here, really quick, this is my y-intercept, so that means it has an intercept at 0, negative 2. And if I want to figure out what the x-intercept is, I make this equal to 0, so you set that to 0. Additive inverse the 2 over here. Divide both sides by 3. So I have 2 over 3 is x, so I'm sorry, that's a negative 1/3. So this would be negative 2/3, 0. So these are the 2 points, my y-intercept, my x-intercept. So this one's down here at negative 2. This one's over here at negative 2/3. So if that's 1, negative 2/3 would be about here. So the line comes down like that. Okay, so again, linear functions, x and y intercept. So all of that comes into play with these quadratics. So before we do it, this is what it's going to look like. So a quadratic function has a shape that's called a parabola. And so this is your basic one, y equals x squared. It looks exactly like this. And then I have this one drawn down here because this is sort of like what we're doing today. Most of the time you're doing this, you have to graph a trinomial, when this is exactly like what we've been working with. So you'll notice something about what a parabola does. What a parabola does is it comes down and then it turns around at some point. This one down here does the same thing. But it does have all of the same things we just talked about with lines. For one thing, you'll notice this end number here, just like on the lines. This end number is going to be the y-intercept. And that's the same with quadratic functions. It's actually the same with all functions. That will be a y-intercept. And then it also has 2 x-intercepts. Linear functions only have 1 x-intercept. Parabolas have 2. You've been factoring and you've been solving quadratic functions, so now you know where the 2 thing comes from. Sometimes there's 1, but a lot of times you're getting 2 answers. Well, here's the reason why. The graph will actually intersect the x-axis twice. And that's also why we set it equal to 0, because just like when you're doing a line, if you want to know what the x-intercept is, you have to make the y equal to 0. So that is the reason why when we were solving by factoring, we set it to 0. Okay, this is how it relates to that. So now what we're going to do is we're actually going to jump right in and graph some. So these are like the ones you're doing today. Now there's a lot more to this, and the reason why this particular video is going to be so long is everything we talk about right now is going to come into play later when things get more difficult. That means the factoring and the solving becomes more difficult, but what's involved with actually graphing these things will always stay the same like today. The same issues come up, x and y intercepts, and then I'll talk about the vertex. So just like when we're solving, what we're going to do is we're going to focus just on this. So we want to find out what the x-intercepts are. Now, when you're doing quadratics, the x-intercepts, what we do is we call those roots. So they'll say, what are the roots of the parabola? So sometimes they'll say x-intercepts, but sometimes you'll have a math book that asks you to find the roots. That's what we're doing here. So we set this to 0, just like when we're solving. So now we have this equation to solve, because we want to find the x-intercept. And then I'm going to factor this. So I can do 1 and 8, I can do 2 and 4, and I think that's it. And to get a -2, this is going to have to be a -4 and a +2. So all of this right now, what I'm doing, it should look pretty familiar because it's everything we were doing when we were solving these things. So the next thing I'm going to do is make my little equations. So I have x plus 2 is equal to 0, and I have x minus 4 is equal to 0. So this one tells me x is 2, and this one tells me, or I'm sorry, that's a -2, and this one is x is equal to 4. So I have to turn these into ordered pairs. If I was solving this, that's it. I write it in brackets, -2, 4. But remember, these are x-intercepts. So one of them is here, and the other one is here. Notice that I'm including the 0 every time because that's what it was set to. So I actually have a pretty good idea what this parabola looks like already. If I sketch it down here really quick, I know a couple of things about it already. I know it goes through -8. 1, 2, 3, 4, 5, 6, 7, 8. I know that that's the y-intercept. I know that it goes through -2. And I know it goes through 4. So I already got a sense of what this thing looks like. The problem is I don't really know exactly where it turns around. So it kind of creates this zone in here where I don't know how far down it goes. I don't know where it turns around. So the question you're asking yourself right now is, how do I know that? And that's where this comes in, what's called the vertex. Now, there's another way to find the vertex, which is called the vertex formula. But a lot of times, especially when it's simple factoring like that, you can do it a different way. You can just kind of reason it out. So if we go back to my picture here, you can see that what happens is the parabola reflects itself. So it's actually, if I cut it down the middle like this, it's like a mirror image. So what that means is wherever the vertex is, it's the same on both sides. So what I really want to find, if you think about it, is I want to find out what's right in the middle. So what's right in the middle of -2 and 4? What number? And that's really easy to do. So what I'm going to do is take -2 and add that to 4. That gives me +2. If I divide that by 2, that gives me 1. So what that tells me is what's called the line of symmetry. Okay? The line of symmetry is at 1, so this is 1 right here, so that is exactly where it turns around. Now, I know it turns around there, but I don't know how far it goes. In other words, I know it's down here somewhere, but I'm trying to figure out where exactly that is. So what you do is you're going to add this and this, you're going to divide it by 2, and you get 1. And then you're going to take that number and you're going to plug it into your equation here, like so. So if I plug in the 1, I have 1 squared minus 2 times 1 minus 8. So all I did was I plugged 1 in for the x. And I get 1 minus 2 minus 8. And that all adds up to -9. Okay, so when x is 1, because I made it 1, y is equal to -9, so that means that it's actually turning, if this is -8, it's right here at 9, it turns. So then I know the parabola actually turns right on that point and comes up through there like that. So now that I know everything, and what I suggest you do is figure out where everything is before you graph it. It just makes it easier. So I know my vertex is at 1, negative 9. So I have my y-intercept, which is 0, negative 8. I have my x-intercepts, and I have my vertex. So when I draw the graph, I know how far I have to make it go. I know what it has to include. So I know on the x-axis I have to go from negative 2 to 4. So what that means is I'm going to have a little bit more over here on the right. 1, 2, 3, 4. And then over here, I have negative 2. Okay, so I know the parabola goes through here and it goes through here. I also know that I need to go down to negative 9. So I'll pull this down a little bit. So I have 1, 2, 3, 4, and that's negative 5, 6, 7, 8, which is our intercept. And then I know the line of symmetry is at 1. And I know it's at 1, negative 9. So that gives me the shape for my parabola. It comes down like this, turns around right here, and then comes back up through the 4. Okay? I know there's a lot there. You're probably going to have to go back and pause the video to make sure you have all the steps right. But that's everything involved with graphing this. Okay? So I'm going to do this other one down here just to give you another example. So the first thing I'm going to do is set this to 0. Then I'm going to factor it. Now it's 3, so that's only a 1 and a 3. And I guess it's a positive 3, negative 1 to get a 2 in the middle. So I have x minus 1, x plus 3. Solve my two equations here. So x is equal to 1 on this one, and x is equal to minus 3 on this one. So I've already got my x-intercepts. I've already got my y-intercept. So all I need to do now is find the vertex. So to find the vertex, what I'm going to do is I'm going to add these up. So here's what you do with the vertex. So I'm going to take 1 and add it to negative 3, which is going to give me a negative 2. And then I divide that by 2, and that's going to give me a negative 1. So I know that that's my x. And then when I want to know the y, here's the formula. It says y is equal to this. So y is equal to negative 1 squared plus 2 times negative 1 minus 3. So y is equal to, this is a 1, minus 2, minus 3. So y would be equal to negative 3 plus negative 2 is negative 5, plus a 1 is a negative 4. So that means my vertex is at negative 1, comma, negative 4. So I have all the points I need. I have my two intercepts, I have my y-intercept, and I have my vertex. So now I'm going to draw that out. Alright, so it looks like my y's are pretty much in the negative side, so I'm going to go ahead and draw my line up here. So I have 1, 2, 3. And then I have 1. And then this one is down here at negative 3. 1, 2, 3. And my line of symmetry was at negative 1, which is here. And I know it's at negative 1, negative 4. There it is. So these are my dots, my points. And there you go. Just connect them all like this and go up like that. And that's how you graph quadratics.